previous class we discussed about Java features, and now we can discuss about what is variable. So variable is reserved memory location to store the data. So variables are used to store the data. So for example, consider how we can declare a variable in Java programming language. The syntax is the syntax is type variable name equal to value. Here the type specifies the type of data type. We have the different data types we can discuss later. Now here the variable name specifies the name of the variable, and equal to specifies the assigned value to the variable name. Next, the value specifies the what value is moved to the variable name. So to declare the variable in Java, the syntax is type variable name equal to value. For example, consider int a equal to 10. Here int is the type and a is the variable name, and 10 is the value. So that means the value of 10 is moved to a variable. So this is the simply how we can declare a variable in Java. Here we have three types of variables in Java. One is the local variable, the second one is the instance variable, and the third one is the static variable. So in Java we have the three types of variables: local variable, instance variable, and the static variable. Now we can see one by one. So what is the local variable? A variable which is declared inside the method is called the local variable. So a variable which is declared inside the method is called local variable. Next, what is the instance variable? So a variable which is declared inside the class but outside the method is called the instance variable. That means a variable which is declared inside the class but outside the method is called the instance variable. Now we can see the example, what is the local variable and what is the instance variable. Next, third variable is the static variable. So a variable is declared as static is called the static variable. What is the advantage of the static variable? When we can create a single copy of the static variable, and that can be used all the instances of the class. So that means we can create only single copy of the static variable. So that variable can be used among all the instances of the class. So in Java we have the three types of variables. Now we can see a small program, a small example. What is local variable, what is instance variable, and what is the static variable. Here we can write a class A. In the class A we can declare two variables and one method. So one variable is the int data equal to 15. Here the data is the class variable, that is called the instance variable. Already we know what is instance variable. The variable which is declared inside the class, outside the method is called instance variable. Here data is the instance variable, since we can declare inside the class but outside the method. So data is the instance variable. Next, M is the static variable. Here we can use the keyword static to declare a variable. So here we can use the static keyword. So that's why M is the static variable. And what is the local variable? Local variable is declared inside the method. Here we have the method void method. In this method we can take n is the variable. So n equal to 90. So here n is a local variable. So in this example, data is instance variable. Next, n is static variable, and the last one, n is the local variable. So in this way, in Java we have the two types of variables. So this is the basic idea about the variable. Now we can see what is the data types. What are the data types we have in Java? So what is data type? So data type specifies the type of the data stored inside a variable. So what type of data we want to move into the variable? Here we have the different types of data: integer values, float values, string values. Now we can see what type of data can be moved into that variable. So here in Java we have the two types of data types. One is the primitive data type and the second one is the non-primitive data type. So we can see one by one what is primitive data type and what are the non-primitive data types. See this example, see this diagram. Here the data types are two types: primitive data type and non-primitive data types. Again, the primitive data types is divided into Boolean and numeric. So to store the Boolean values, we can use Boolean data type. Similarly, the numeric is divided into two types. One is the character and the second one is the integral. So to store the character values, character data, we can use the char data type. Next one, the integral is divided into two types: integers and floating point. So to store the integer values, we have the four data types. One is the byte, second one is the short, third one is the int, and fourth one is the long. To store the floating point data, we have the two types of data types. One is the float and double, second one is the double. So totally we have 8 primitive data types. That 8 primitive data types are: first one Boolean, char, byte, short, int, long, float, double. Here to store the integer values, we have the 4 data types. To store the float values, we have the 2 data types. To store the character value, we have the 1 data type. To store the Boolean values, we have the 1 data type. So totally we have the 8 primitive data types. Next, the non-primitive data types are string, array. These are the examples of the non-primitive data types. We can see what are the non-primitive data types. Now we can discuss one by one. What is byte, what is int, what is short, and what is long. So first we can see the one by one. So we have the totally 8 primitive data types. Already we see byte, short, int, long, float, double, char, and Boolean. So now we can see one by one. What is byte? What is the size of byte? What is short? What is the size of short? The first one is the byte. So byte is a data type. Already we know. So this is the 8-bit signed 2's complement integer. So in the byte data type, we can store byte data type size is 8-bit. So here the minimum value to store the byte value is -28, that is -2^7. The maximum value for the byte is 127. So here the default value for the byte is 0. So the default value for the byte is 0. Why we can use the byte data type? So byte data type is 4 times smaller than the integer. 4 times smaller than the integer. So here the byte data type used to save the memory space. So byte data type is used to save the memory space because the byte takes 4 times smaller than an integer. So how to declare a byte data type? For example, byte a equal to 100. Here byte is the data type and a is the variable name and 100 is the value. That means the value of 100 is moved to the variable name A. So here A is the byte data type. Similarly, byte B equal to 50. That means the 50 minus 50 value is moved to the B. That is the byte data type. So already remember this point. The byte data type range is minus 128 to 127. That means minus 2 power 7 to 2 power 7 minus 1. So this is the byte data type. Next we can see the next data type, short data type. The short data type is size is 16 bit. That is 16 bit signed 2's complement integer. Here the minimum value of the short is minus 2 power 15. That is converted into minus 32,768. The maximum value of the short is 2 power 15 minus 1. That is 32,767. So the range of this short is minus 32,768 to 32,767. Again, the advantage of this short is it will take the less memory space compared to the integer. So short is the 2 times smaller than the integer. So when we declare the short data type, the default value for the short data type is 0. So example, consider short s equal to 10,000. Here short is the data type, s is the integer variable name, and 10,000 is the value. So the 10,000 value is moved to the s variable name. Similarly, short r equal to minus 20,000. So minus 20,000 value is moved to the variable name r of type short. So this is the, so we remember that one point. So the short range is minus 32,768 to 32,767. So this is the short data type. Next one is the int data type. The int data type size is 32 bit. That means the int data type is 32 bit signed 2's complement integer. The minimum value of the integer is minus 2 power 31. That value is converted into, so this is the minimum value of the int. Next, what is the maximum range of the int? The maximum range of the int is 2 power 31 minus 1. That is, the value is, this is the maximum value of the integer. So that means the range of the int data type is minus 2 power 31 to 2 power 31 minus 1. So generally, regularly we can use the integer data type as the default data type to store the integer values. So the default value of the integer is 0. The default value of the integer is 0. So consider example, int a equal to 10,000. So a is the integer data type. In that a variable name, we can store the 1 lakh value. Similarly, int b equal to minus 20,000. So in this way, we can use the integer data type. The next one is the long data type. So the long data type is 64-bit signed 2's complement integer. So the range of the long data type is, the minimum value of the long data type is minus 2 power 63. The maximum value of the long data type is 2 power 63 minus 1. So when we convert minus 2 power 63 into integer value, so this is the integer value of minus 2 power 63. So the range of the long data type is minus 2 power 63 to 2 power 63 minus 1. So this type is used to store the wider range than the integer value. Next, The default value of the long is 0 here. So next example is long A equal to 1 lakh L. So the difference between the int and the long is, we can put L for the long. So for example, int A equal to 100. So A is the integer data type. For example, long B equal to 100 L. When we put the L, that means this will take the longer value. That means the B variable is the long data type. So this is the long data type. Next, we can see the float data type. The float data type and double data type are used to store the fractional value and floating point values. So in the float data type is single precision 32-bit IEEE 754 floating point. That means the float data type follows a standard. That standard is 32-bit IEEE 754 standard. The float data type is used to save the memory space compared to the double data type. The default value of the float data type is 0.0f. So for example, float f1 equal to 234.5f. So that means here f1 is the float data type. The value stored in the f1 is 234.5. So remember one point, the float data type is this one, single precision 32-bit. It follows standards IEEE 754. So remember that's all. Next we can see what is the double data type. So the double data type is also a standard, that is double precision 64-bit IEEE 754 floating point. That means the double data type follow a standard. That standard is IEEE 754 standards. So this is the I think double precision 64-bit IEEE 754 floating point. So generally this data type is used to store the decimal values. So this is the default data type to store the decimal data type. Example, the default value for the double data type is 0.0 or 0.0d. So next example is double D1 equal to 123.4. So this is the double data type. So remember, for the float and double follows the standard IEEE 754. Float is the single precision 32-bit and double is the double precision 64-bit. So remember these 2 points. Next one is the Boolean data type. So the Boolean data type is used to store the 1 bit of information, that is either 0 or 1. So that means we can also call as true and false. So true and false. So generally 0 means false value and 1 means true value. So the Boolean data type is used to store the 2 values. One is the true value and the second one is the false value. The default value of the Boolean data type is false. For example, Boolean A equal to true. That means a true value is moved to the A of type Boolean. So this is the Boolean data type. And the last primitive data type is the char. So to store the characters in the Java, we can follow a Unicode format. So to store the character, we can follow Unicode character format. Here we have the different types of character formats. Already we know ASCII format, and the second one is the Unicode format. Here Java follows the Unicode character format. The size is 16-bit size. Here the minimum value of the char is /u 4 zeros. That is simply called as 0. The /u specifies the Unicode format and 40 specifies the 0. So next, the maximum value of the character value is /u 4fs. This is the hexadecimal format. When we convert the hexadecimal format into decimal value, the value is 65,535. So that means in the decimal format, the character range is 0 to 65,535. But in the hexadecimal format, the range is 4 zeros to 4fs. So this is the Unicode format. Example, char a equal to a. That means a character is stored into the a variable name. So this is the character data type. So totally in Java we have the 8 primitive data types. So to store the integer values, the data types are short, int, long, byte. And to store the float values, the data types are float and double. To store the boolean values, the data type is the boolean. To store the character values, the data type is the char. So this is the basic idea about the boolean, data types in Java. Next we can see a small program for the data types. Here we can write a program. Already we know in Java compulsory we need at least one class to write a main method. So here the class name is data types. Data types is the class name. So in the data types class we can write a main method. Main method already we know: public, static, void, main, string, aux. You know what is public, what is static, what is void, what is main. So now we can declare the different variables. First one is the byte var, is the variable name to store the byte value. Similarly, short var is the variable name to store the short value. Next, int var is the variable name to store the integer value. Next one, long var is the variable name to store the long values. Next, float var is the variable name to store the float values. Similarly, the double var is the variable name to store the double values. Similarly, boolean var is the variable name to store the boolean values. Similarly, char var is the variable name to store the character value. So totally we have the 8 variables. One is the byte var to store the byte variable, byte data. Short var is used to store the short value. Int var is used to store the integer value. Long var is used to store the long value. Float variable name is used to store the float value. Similarly, we have the totally 8. So here byte var equal to 5. That means 5 value is stored into the byte variable. So based on that one, just we can assign the different values to the variable names of different data types. Now simply we can print the value of the byte, value of the short. So for that, to print the data in Java, we can use the statement system.out.println. So value of the byte variable is, next it will print the byte value. So the output of this program is value of byte variable is, what is the byte value? 5. So it will print this one. Similarly, system.out.println, value of the short variable is plus short var. For the output for the statement is value of short variable is, what is the short value? 20. So it will print the 20. So similarly, the next output is value of the int variable is, what is the int value? 30. Next, value of the long variable is, what is the long value? 60. So the output is value of the long variable is 60. Next, the value of the float variable is, what is the float value? 20. 0.0. Next, value of the double variable is, the double value is the 20.123. Similarly, the value of the Boolean variable is, what is the Boolean variable value? True. So the output is value of the Boolean variable is true. Similarly, the value of the char variable is, what is the char value? W. So the output is value of the char variable is W. So the output is displayed in this way. Value of the byte variable is 5, value of the short variable is 20, value of the integer variable is 30, value of the long variable is 60, value of the float variable is 20.0, value of the double variable is 20.123, value of the Boolean variable is true, and last one is the value of the char variable is W. So this is the output for this program. So this is the simple program. So this is the data types. Next concept is primitive type conversion and casting. So what is primitive type conversion and casting? So simply in Java we have the 8 data types. We can convert one data type into the value into the another data type. So in Java, typecasting is a method or process that converts a data type into another data types in 2 ways. One is the manual way and the second one is the automatic way. So what is typecasting? The typecasting is the method that will convert one data type into the another data type. Have 2 ways. One is the automatic way and the second one is the manual way. So when automatically converted and when the manual process can be used to convert one data type to another data type. So here we have the 2 ways. If the data types are compatible, then Java will perform automatic conversion. If the data types are not compatible, the programmer need to manually convert it. That means the programmer explicitly convert one data type to another data type. So that means if the data types are compatible, the Java will automatically convert one data type into another data type. If the data types are not compatible, the programmer, that means we need to perform the type conversion. So here we have the 2 types of conversions. One is the automatic conversion and the second one is the manual conversion. So the automatic conversion is called implicit casting and the manual conversion is called explicit casting. So here in Java we have the 2 types of casting. One is the implicit casting and the second one is the explicit casting. The implicit casting is also called as widening conversion. The explicit casting is also called as narrowing conversion. So what is implicit casting? If the data types are compatible, then automatically Java will perform typecasting. The type of typecasting is called implicit casting. That means a data type of lower size is assigned to data type of higher size. So the lower size is easily converted into the higher size data type. So this is called a widening conversion. So this process is automatically done in the Java. So we can see a diagram. Here the diagram is, the byte is the lower size compared to short. That means the byte is converted into the short. Similarly, short is the lower size compared to int. That means short is easily converted into the int. Similarly, int is converted into the long. Long is automatically converted into the float. Again, float is automatically converted into the double. Similarly, the char is automatically converted into the int. That means the lower size is automatically converted into the higher size. That is called implicit casting or wiping conversion. So this can be done automatically in Java. We can see an example. Consider a small program for the automatic conversion or implicit conversion. Example, consider int I equal to 100. I is the int data type that will store the 100 value. Now we convert the I into the L. So I size is smaller compared to L size. That means the I is easily converted into the higher size, that is long. So simply long L equal to I. That means the I value is moved to the L value of data type long. So this one automatically done by the Java. Similarly, float F equal to L. So compared to L, F float data type is the higher size. That's why L is converted into the float data type. So in this example, we are converting I to L, L to F. So I is the lower size compared to L. So easily perform the conversion. Next, L is the lower size compared to the float. So this can be done also implicitly by the Java. So the output of this program is, what is the int value in the I is the 100. So the output is int value 100. Next, system.out.println long value. Long value is the L value. I value is moved to the L. That means the output is 100. Next, system.out.println float value. Float value F. The F value is came from M. So that means 100 dot 0. So this is the output of this program. So in this program, I integer value is easily converted into the long data type. The L value, long data type, is easily converted into the float value. So the output is 100, 100, 100.0. So this is the implicit casting. Next we can see the concept of explicit casting. Explicit casting means if the data types are not compatible, then the programmer need to perform the explicit casting. That means a data type of higher size cannot be converted into the data type of the lower size. So higher size data type is not possible to convert into the lower data type. So in this case, the programmer need to perform this operation. Example C, the double value is the higher. Next, float is the lower size. Next, float compared to long. Long compared to int is the lower size. Into short, short to byte. So when we perform higher size to the lower size, the programmer need to convert. So this cannot done by the automatically in Java. So further, we can see the program. The program for the explicit casting is, consider double D equal to 100.04. So D equal to 100.04 of type double. Next, now we want to try to convert the double value into the L. So here not possible since the double is the higher data size compared to the L. So we need to perform the explicit casting. That means the D value explicitly convert into the long. So now we are converting the D value into the long. then we can move that value into another variable. So this is the explicit casting. So first we can initially convert into the d value into the long, then that value is moved to the n. Similarly, the long value is moved to the I. The long n is the higher size compared to the int. Int is the lower size. So this is also not possible in Java. So now we can convert into the explicitly. For that, L value initially convert into the int. So L value is converted into the int. Now that value is moved to the int I. So in this way, we can perform the explicit casting in Java. So the drawback of this explicit casting is there may be data loss. There may be data loss. For example, system.out.println double value d. That means the output is double value. Where the value we are storing in d? 100.04. Next, system.out.println long value. Long value. In the here we lost a data. There is a fractional part we can lost. That means the output is 100. Why? Because we are converting the double data type into the lower and long data type. Similarly, the int value, the output is 100. So in the explicit casting, there may be a data loss. So these are the type casting, how we can convert one data type into the another data type. Here we have the two ways, implicit casting and the explicit casting. Implicit casting is done automatically by the Java. In the explicit casting, the programmer need to perform the explicit casting. So thank you for this session. So tomorrow we will discuss the remaining concept.